In this video, I will go over how to do the box itself with a very simple rigid body simulation. I already covered how to do the sparks and the ground deformation in 2 videos. I will link to both of them in the description below this video. So first off, I'm going to put down a geometry object. Dive inside and put down a box. I'm just gonna place it a little bit above the ground or above 0. And then I'm gonna put down a RBD configure. I'm going to connect the box to the first and the third input of the RBD figure. First input is the render geometry and the third input is the proxy geometry. So here we set the properties of the box. So in the geometry spreadsheet, if you choose the proxy geometry, you'll get some information about the simulation object, the box, that is set inside this node. So for example, it has the density of 1000 and it has the bounds of 0.25. So instead of using this drop down, you can also just put down a null and connect it to the third input to see all the information about the proxy geometry. So now I can add the RBD bullet solver and connect all the inputs. We don't have any constraints, so it doesn't really matter if you connect it or not. Move the blue flag, press play, and the box will just fall down. Then inside of collision, I'm gonna add the ground, so just the ground plane. Let's see how this goes. And then toggle real time to limit the playback speed to 24 frames per second as it is set here. Now to push the box, I'm going to give it some attributes before the RBD configure node. So I'm going to put down first a null, just so it's easier to add nodes here without having always to connect it to both inputs. And then I'm going to put down an attribute swap. Dive inside. And I'm just going to give it some velocity. So let's see, let's push it in the direction of x. So I'm just going to put down a constant. I'm going to make it a vector. Then I'm just going to set it to 10, 0, 0. And plug it into the output velocity. So if we go up here, you can see we have this velocity on the box. Notice in the RBD configure node, you have this option to transfer attributes, and by default, the velocity attribute is transferred. Let's play the simulation again. And we shoot the box off to the right. I wanna also push it to the ground, so I'm gonna go back in here, maybe give it -5 in y, and increase this value 20 in x and -5 in y. So now let's try playing it again, and it shoots off a little harder. And we can also give it some angular velocity. So that is W. And that attribute is also transferred by default from whatever you're plugging into the RBD configure node. So inside of here, for the angular velocity, I'm going to put down another constant. And it's also going to be a vector. And let's just have it spin around y maybe. So we can put y to, I don't know, let's try 30. And I'm going to export it to an attribute called W. So I'm going to put down a bind export. I'm going to change the name to W and the type to vector. And now let's play again. If we unplug V just to see that W is working, yeah, it's spinning. Probably too much. Let's just put it to 10. Yeah, maybe something like this, and let's try the two together, both V and W. Something like this. Spinning a lot, probably too much. So we might wanna, for example, visit the RBD bullet solver, and we can add some drag in forces, a little bit of drag. And another thing I would like to do to have the box slide across the ground, I'm going to decrease the friction of the object. So in here, you can toggle friction. And you can see you have a friction parameter here. And I'm going to set my own friction. So I'm going to toggle user friction. And then I'm just going to set this to 0. Let's see how this looks. And now it slides across the ground. You can just add a little bit of friction. Let's try 0.3. But you can really just play around with these parameters and see what works for you. The ground also has friction. So in collision, you can set the friction of the ground here. And you can also set the bounce of the ground. But for now, I'm just going to keep it like this. If you take a look at the info card up here, you can see we have 8 points and 6 primitives, but then in the RBD configure node, we have 1 point and 1 primitive. That is because the box has been packed, and it stays packed throughout the simulation. So after the simulation, we can unpack the box. And I'm just gonna grab the render geometry from the first input. Oh, the blue flag. And now we have 8 points and 6 primitives. We got position, P, velocity, V, and then the angular velocity W. And then we got some other attributes down here. This is the name attribute, which is a string. It's on the primitive, so you can see it in here. And then we got a detail attribute. So I'm just gonna delete the attribute I'm not gonna be using. So I'm gonna put down an attribute delete. And in here, I'm gonna keep these 3. I'm just gonna delete the name for now and this one. Now I need the camera. So I'm just gonna shorten the timeline to, I don't know, 60. And maybe a little more, 80. Then I'm just gonna move the viewport somewhere around where I would like my camera to be. So let's see how this would look. Yeah, and if you're happy with the position, you can just click no cam in the top left corner and select new camera. And we get this camera here. If you would like to adjust it a little bit, you can either press enter and use these, but you can also lock the scene view to the camera. So now if you move in the scene view, you move the camera as well. Just remember to unlock it, because otherwise you'll mess up your camera. So this is just something off the top of my head. I actually have the box simulation setup that I used for the sparks. So here we have the camera and the system. I placed the box a little bit off the ground. I rotated it. I gave it some velocity. So I multiplied the velocity by 5 because I like the direction. So this is basically 50 and minus 10. Then I gave it some angular velocity as well. I decreased the bouncing of the simulation object and the friction as well. And you can see here in the proxy geometry, friction and bounce. You can also use these presets. Just keep in mind the parameters, for example, the density won't update until you choose one of these as well. So for example, steel, You can see you now have the density of 8,050 kilograms per square meters. If you don't do that, keep it as default, it will stay as 1,000, which is basically the density of water. In my case, I just kept it as concrete and default. Then in the simulation, in the collision, I removed the bounce and I increased the friction. One thing that is pretty helpful is if a parameter has been changed from its default value, the value will be in bold. Then I added a little bit of drag and then also a drag on the spinning as well. I will put a link to my actual iteration process where I was dialing in these values in the description below this video. I did recompute the velocity at the end. It's not necessary because you do have the velocity from the simulation, but I just sometimes do this just in case. Now to write the box out to disk, we can put down a ROP Alembic output node. Connect it. I'm going to render the full frame range and then give it some name, for example, sparks, box, and then in case if I update it in the future, I'm going to say dot version 001 and save the disk. I also want to write the camera out to an Alembic, so upstairs I'm going to go File, Export, Alembic, and in here I'm just going to call it Sparks Camera and keep the version 001 in case I'll update it later as F. And then I'm just going to drag and drop this camera into this export and export. Now inside of a fresh scene, I'm going to import the camera Alembic. So I'm going to say File, Import, and then Alembic Scene. In here, I'm going to choose the camera as F, import, and we got the camera. We can set the view to this camera. Then we can put down a geometry context. Dive inside and put down an Alembic node. And in here we can choose the box. So now we have imported both the camera and the box.